The National Electrical Code, or NEC, dictates that if a receptacle is fed by a number 12 wire on a 20 amp circuit, any downstream devices connected to that receptacle must also be fed by number 12 wire. This is primarily because the ampacity of the wire must be sufficient to handle the maximum load that could potentially be connected to it. In this particular scenario, the number 12 wire is rated for 20 amps, and therefore any downstream devices must also be protected by 20 amp overcurrent protection. The practice of using number 14 wire to feed lights from a receptacle that is originally fed by number 12 wire is not permitted according to the NEC. The reason for this restriction lies in the fact that number 14 wire is only rated for 15 amps. This is a lower amperage than the 20 amps that the receptacle is protected by. If a device drawing more than 15 amps were to be connected to the number 14 wire, it could potentially overload the wire, which could lead to a fire hazard. Therefore, it is necessary to maintain the number 12 wire throughout the entire branch circuit, even if the load on the number 14 wire for the lights is only a couple of amps. The NEC sets minimum standards for electrical safety, and these standards are in place to protect people and property from electrical hazards. Using the correct wire size is an important part of ensuring electrical safety. The NEC outlines approved wiring methods in Chapter 3. Article 300.14 talks about length of free conductors at outlets, junctions and switch points. At least 6 inches of free conductor length measured from the point in the box where it emerges from its raceway or cable sheath must be left at each outlet, junction, and switch point for splices or connections to luminaires or devices. This can be important when replacing devices in the future. Article 310 covers conductors for general wiring and is very informative and necessary to understand. Firstly, 310.1 provides the scope of Article 310. Secondly, 310.2 dictates conductors shall be insulated, suitable for the voltage, suitable for the conditions of use and installed in accordance with all applicable provisions of the code. Thirdly, 310.3 talks about the stranding of conductors. Where installed in a raceway, conductors of size 8 American wire gauge and larger shall be stranded. 310.4 details conductors in parallel. Aluminum, copper-clad aluminum, or copper conductors of size 1/0 American wire gauge and larger, comprising each phase, neutral, or grounded circuit, shall be permitted to be connected in parallel. The requirements in 310.10 must be met for ampacity. Conductors shall be protected in accordance with their ampacities. 310.15 is about ampacity tables. 310.15 Bone explains that the ampacity of a conductor shall be determined by referring to the appropriate table in 310.15, as modified by 310.15b2 through 310.15b7. The ampacity is the current, in amps, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The temperature rating of a conductor is the maximum temperature that the conductor can withstand without deteriorating. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides ampacity tables for different types of conductors under different conditions. These tables can be used to determine the appropriate size of conductor for a particular application. For example, Table 310.15b16 lists the ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. If you have 3 number 12 American wire gauge copper conductors with THHN insulation in a raceway and the ambient temperature is 30 degrees Celsius, then the ampacity of the conductors is 30 amps. However, if the ambient temperature is 40 degrees Celsius, then the ampacity of the conductors is reduced to 24 amps. This is because the higher ambient temperature causes the conductors to heat up more, which reduces their ability to carry current. You should always consult the NEC and other applicable codes and standards before installing any electrical wiring. This will help you to ensure that the wiring is installed safely and in accordance with all applicable requirements. Using number 14 wire on a 20 amp circuit is a violation of the NEC and could create a fire hazard. Always use the correct size wire for the circuit you are working on. When dealing with electrical circuits, it is crucial to ensure the correct wire gauge is used in relation to the circuit's overcurrent protection. The National Electrical Code sets the standards for safe electrical installations, and it is essential to adhere to these regulations to prevent potential hazards. Consider a scenario where a receptacle is fed by a number 12 wire on a 20 amp circuit. The NEC mandates that any downstream devices connected to this receptacle must also be wired with number 12 wire. This is because the wire's ampacity, or current carrying capacity, must be sufficient to handle the maximum load that could be connected to the circuit. In this case, the number 12 wire is rated for 20 amps, ensuring it can safely handle the circuit's potential load. Consequently, any devices connected downstream must also be protected by a 20 amp overcurrent protection device such as a circuit breaker or fuse. Using number 14 wire to feed lights from a receptacle that is supplied by number 12 wire is not permitted by the NEC. Number 14 wire has a lower ampacity rating of only 15 amps. If a device drawing more than 15 amps were to be connected to the number 14 wire, it could overload the wire, leading to overheating and potentially causing a fire. To maintain electrical safety and code compliance, it is necessary to use number 12 wire throughout the entire branch circuit, even if the lights connected to the number 14 wire draw only a couple of amps. The NEC prioritizes safety and sets minimum standards to prevent electrical hazards. By adhering to these standards, you can significantly reduce the risk of electrical fires and ensure the safety of people and property. In essence, using the correct wire size is critical for safe electrical installations. Always consult the NEC and other applicable codes and standards to determine the appropriate wire size for a particular application. Additionally, ensure that all electrical work is performed by qualified professionals who are knowledgeable about electrical codes and safety practices. In summary, never use a smaller gauge wire than what is required for the circuit's overcurrent protection. Doing so can create a dangerous situation and violate electrical codes. Instead, always prioritize safety and adhere to the NEC guidelines to ensure that your electrical installations are safe and compliant. When dealing with electrical circuits, it is essential to understand the relationship between wire gauge and ampacity. Wire gauge refers to the physical size of the wire, while ampacity is the maximum amount of electrical current a wire can safely carry. The NEC provides guidelines for selecting the appropriate wire gauge for various circuit amperages. For example, number 14 copper wire is typically rated for 15 amps, number 12 copper wire is rated for 20 amps, and number 10 copper wire is rated for 30 amps. It is important to note that these ampacity ratings are based on specific conditions such as the type of insulation, ambient temperature, and number of conductors in a raceway or cable. When selecting wire for a circuit, it is crucial to consider the circuit's overcurrent protection device, such as a circuit breaker or fuse. The overcurrent protection device is designed to protect the circuit from overloads and short circuits. The wire gauge must be sufficient to handle the maximum current that the overcurrent protection device allows. If the wire gauge is too small for the circuit's amperage, it can overheat and potentially cause a fire. For example, if a 20 amp circuit is wired with number 14 wire, the wire could overheat and create a fire hazard. Therefore, it is essential to use number 12 wire for a 20 amp circuit. In addition to the NEC, local electrical codes may also have specific requirements for wire gauge and ampacity. It is essential to consult these codes to ensure that your electrical installations comply with all applicable regulations. Proper wiring is not just about safety, it also affects the performance and reliability of electrical systems. Using the correct wire gauge can prevent voltage drops, which can cause lights to dim and appliances to malfunction. Additionally, proper wiring can reduce the risk of electrical noise, which can interfere with electronic equipment. When working with electrical wiring, it is always important to follow safety precautions. Turn off the power to the circuit before working on it, and use insulated tools to avoid electrical shock. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work. The NEC provides specific guidelines for electrical installations, including the selection of wire gauge, overcurrent protection devices, and other components. Adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. For example, the NEC specifies the minimum size of conductors for various types of circuits. It also specifies the type of overcurrent protection device that must be used for each circuit. By following the NEC guidelines, you can ensure that your electrical installations are safe and compliant. In conclusion, using the correct wire gauge is critical for safe electrical installations. Always select the appropriate wire gauge for the circuit's amperage and overcurrent protection device. Consult the NEC and local electrical codes to ensure compliance with all applicable regulations. And if you are not comfortable working with electrical wiring, hire a qualified electrician to do the work. Remember, electrical safety is paramount.